So today I'm going to talk about what we're calling semantic fingerprinting and how we're using that technology in our disambiguation processes. So once we have a thesaurus, and once you've tagged your content, you have a huge lever that you can use as a wedge for all kinds of wonderful things. Search and discovery of content, retrieval, and among those things is what we're calling semantic fingerprinting. So once you have a corpus of content tagged with indexing terms, you can start to make generalizations. Not only can you say, this is what a paper is about, you can take a bunch of papers by an author and say, these are the subjects that an author writes on. You can take a bunch of papers, probably a whole bunch of papers, that come from an institution, Harvard or Johns Hopkins, and make a generalization. Here are the subjects Harvard is publishing on. Here are the subjects Harvard has published on for the last 100 years, or 10 years, or in a change of time over years. And so we're calling this a semantic fingerprint. So if paper can have a semantic fingerprint, an author can have a semantic fingerprint. Increasingly, we use the same technology either from an editor's papers they've edited or that they choose from a taxonomy to give an editor or a reviewer a semantic fingerprint. So I want to talk a little bit about how we're using that technology to do disambiguation processes. So what's the problem? The problem is that we have tons and tons of content. Some of us have 900,000 articles dating back to 1880, and in the sciences, which many of you publish in, maybe you have an average of 3.5 authors per article. So that's like 3 million names, 3.5 million names. That's a lot of names of authors. And in order to make consistent semantic fingerprints and offer this as an option for people to browse, let's say you want to follow a particular author on a website, we need to figure out which authors are which when they have similar names. Authors, editors, lists of members, lists of employees, and increasingly, I'm finding when I talk to publishers that the marketing department keeps their members list, and somewhere in the publishing department they keep a list of authors, but then over here is the list of authors that actually comes from the data, and these lists aren't talking to one another. So ideally your members and your authors lists would be merged so that if a member says, hey, can I see all the papers I published with you? You don't have to go on a big data scramble and hire a freelance programmer to do so. And the same thing applies to institutions. So why do we need to disambiguate? So you can browse by author, so you can browse by institution, so you can resolve the list between the marketing department, the membership department, the editorial department. And increasingly now we're seeing the rise of these universal databases such as ORCID. People come to me when I talk to them about disambiguation and they say, well, isn't ORCID going to solve that problem? I said, no, you have to solve your own internal problems before you can make use of ORCID. If you have 10 J.R. Smiths, and one of them is John R. Smith, and one's James R. Smith, and one's J. Roger Smith, and you don't know which ones of those are the same and which ones are different, there's no way you can link out to ORCID. They think they can just slug an ORCID ID into all their back file and make the disambiguation problem go away, but they've got it backwards. They have to solve their disambiguation problem before they can link out to ORCID in any kind of automatic or consistent way. It's also a great way to demonstrate values to stakeholders. So you're in the editorial department and you're excited because you need to implement a taxonomy because it's going to make your life easier and you can do all these great things with it. So you have this project and then you need to tell your boss and your boss's boss why you did this and how it's adding value. So if you can say, go to a university, I go to the University of California at Davis, who's thinking about pulling their subscription to my journal, and I can say, 8 of your 10 agricultural faculty are publishing in our journal. Then the library can justify not canceling your subscription, and you can tell your boss that you're saving them from losing sales. And you can also do market research and analysis. Once you know which J.R. Smith is James R. Smith and which one is John Roger Smith, then you can do statistical analysis on your papers. So, what are we talking about? We're talking about disambiguation. There's a few different processes that go on, and to make it very, very simplistic, oversimplistic, you can look for exact string matches and you can look for fuzzy matches. Exact string matches means J.R. Smith equals J.R. Smith. Fuzzy matches let the computer take into account variations in typography, variations in typing, and some other things. And then, once we have a set of names that we suspect are the same, we look at other things associated with those names. What country did they publish in? What date did they publish on? Who did they publish with? So co-citation actually ends up being a very useful tool in trying to distinguish authors from one another. And then what we bring to the table with our tools, of course, is the semantic fingerprint aspect of this. So you have this huge set of data. And first of all, you have to resolve the back files, right? So just as all the other things we're doing in our publishing processes, we have a massive back file. And then as that happens, we have new work that's incoming. So the first thing we want to do is resolve our back file into a good authority file. We can keep iteratively cleaning it, but once we're relatively sure it's in decent shape, then as we have data incoming, we can match it against what we think is a pretty clean file. And the way we've set it up is that if you can't match it with a computer to a certain degree of accuracy, whatever you're sure is a pretty good match, it gets kicked out to an editor in an interface, and they can look at it by hand to decide if it's a new author or if it actually matches someone in the database. So as new content comes in, authors, assuming it's well tagged in well-formed XML, authors and institutions are extracted from it, and then they're compared against the existing authority file, and the anomalies are reviewed. So having a clean institution file really helps. So even if you have hundreds of thousands of articles, that might mean you have millions of unique authors. But that probably means you maybe have 20 or 30,000 unique institutions, and that includes laboratories, of course, universities and colleges, sometimes private businesses have research departments. You're not going to have nearly as many institution unique names as you will author unique names. So having a clean institution file really helps you do your author disambiguation. And it lets you develop standards and practices. It lets you get your fingers in the data and have that firsthand experience digging around in it, so that when you go to do your authors, you've already gotten your fingers dirty in the data. So how does the institution disambiguation work? Well, very simply, you have a whole lot of data that you've pulled, which comes in as raw names. You run it through a disambiguation algorithm. You send it to the disambiguation algorithm. It does as many matches as it can. It suspects that things are matching. It lumps them together in a file. There's a QC process. Anything that doesn't match gets kicked out and reviewed by an editor. Those things go in the institution file, and the process is iterative until you're relatively sure you have a pretty good list to work with. The quality of your raw data matters. If your data is not well tagged, you have to guess which ones are the institutions. You have to guess where the institutions are. So having structured data really helps take some of the guesswork out of this process. And obviously, as many of you are deeply aware, your legacy content might not be structured at all. It might have been structured post facto, and probably by some automatic process. So the things that are in the tag that says it's an institution is not always as reliable as we would like. So you have to watch out for some discrepancies there. And so what you take is what you suspect to be the institution name and parse it out using some stop words and delimiters to try and assemble what you think is a good name. And it really helps if you have some country institution that you can pull out of the author record or the email or the institution name, because there are a lot of institutions in a lot of places that sound an awful lot alike if you don't know which country that they're from. I had a mental example, I don't remember what it was, but there's an institution in Canada, I think it's University of London, there's one in Ontario or something, that sounds an awful lot like it's in the UK. So what are we talking about? So I pulled some raw data. This is completely undisambiguated data. So we have Ohio Aerospace Cleveland, Ohio, which sounds like it's probably the Ohio Aerospace Institute. And you can see that, and I can see that. What we have to decide is whether our computer algorithm can see that, or that gets reviewed by an editor. We have Ohio Dominican University, the Ohio Institute of Technology, Ohio Northern University, Ohio State University in Columbus, with an extra zip code, with a Department of Linguistics, with a different department, with the city, state, zip, and someone's email appended to it. And then we have Ohio University, which we happen to know is actually not the same as Ohio State University or Ohio Northern University or any of these other ones, that it's an independent institution. But if you're not careful, a well-meaning algorithm could match Ohio University to Ohio State University. So the problems are very granular. So this is where the human editorial review comes in, which is something that we do a little bit of every day. So there's two types. One is a QC. You have to check the stuff that was done automatically. Sorry, that was John Krantz talking. You have to do the stuff that was done automatically to make sure your algorithm's working well, and refine the ongoing process. And then you have to review the things that aren't matched and decide if it's actually something new, or maybe it does match. The computer wasn't sure enough to match it, but you can go ahead and match it to an existing record. So we've designed a simple Java editorial interface. This is what our editors work in. We're refining it a little bit right now. I think most of the names have been scrubbed to protect most of the innocent. So here's an incoming record, Philip Morris International, research development, something, something in Switzerland, and you can't see the whole thing down here because there were several Philip Morrises. Anyway, don't need to explain the whole process, but the editor gets raw data in that they need to match. They can look up in the existing authority file by institution name, state, city, department, to see if there's anything in the back file that they can match it to, if the computer wasn't sure enough. So now we're on to doing the same thing with people. People are trickier than institutions are. Yeah, go ahead, Kev.
How do you deal with hospitals?
It depends on the client. Some clients don't care if University of New Mexico Hospital and University of New Mexico are the same institution. Some institutions, some clients, if they have a lot of medical data, absolutely want the hospital to be kept separate. University of New Mexico Hospital is a different institution than University of New Mexico, or it's a sub-institution like a department or a laboratory. But you have to be careful. It's very easy to smush them all together. So, with authors, in a lot of legacy content, people just put their initials. J. Smith, Harvard University. Today that seems ludicrous, but a lot of times it was the style sheet of the journal they published in at the time. First initial, middle initial, last name. Today, of course, when native digital content is created, people provide as much information as possible. So again, a lot of the problems go back to legacy content, but even today, oftentimes, especially non-American authors will only offer first initial and last name, and so there's a lot of ambiguity in author records. So we have nicknames, middle names, initials, prefixes. Transliteration is a problem. Name changes.
Typos.
I'm sorry?
You forgot typos.
And typos are always a problem. And as Alex will tell you, stuff shows up in the tags that you would think would be completely unambiguous. And the last name field says, received a grant from the Foundation and the research of dreams, and we were really hoping to achieve and so it gets pretty ludicrous. So again, we have raw data. So again, I pulled a random sample of raw data. So we have N. Carson, Neil N. Carson, same guy? Maybe they know each other, and the reason the one guy goes by Neil N is so he doesn't get confused with the other guy. P. Carson, R.L. Carson, are M.K. Carson, R.W. Carson, Roy Carson. So Roy could be any of these, but he could be Roy F., but maybe not. And then T.A., Thomas A., Thomas J. So Thomas could be T.A. or Thomas A. or Thomas J. And Thomas A. can't be Thomas J., but Thomas A. could be, so you see where I'm going with this. And when this list runs into the millions, you see the extent of the problem we're trying to deal with. So which of these, if any, are the same person? Well, that's what we're trying to figure out. So we take the raw data from the source files, take the name out, take the co-authors out, take the institutions out, take the subject terms out, and put them in our magic box, which I'll talk a little bit more about. And then the workflow is pretty much the same as the institutions. There's a name of file that gets checked against. We already have a repository of thesaurus terms that are connected with the authority file. This is the fingerprints. An institution authority file. The co-authors are, of course, already in here. Anything that doesn't match gets kicked out to an editor to review. You add it to the authority file, and the process goes on. So what are we talking about? We're talking about we have a bunch of potential matches in the existing file with an author that needs to be matched. We can check the relative affiliations. If you have a guy and you're not sure if Neil N. Carter is the same as Neil Carter, were they both at Harvard? If not, the guy that was at Harvard, you have a fairly high certainty that it's a better match. Do they have any of the same co-authors on a paper? That's an extremely good indicator that it's the same guy. Email addresses, when available, we thought would be great. Turns out not as good an indicator. We thought it would be a lock. If they have the same email address, it's a lock. Well, unfortunately, that's not the case. And then our extra sauce is the semantic fingerprint. So if you have two guys, you're just not sure if Neil Smith is Neil N. Smith or N.N. Smith, and this guy publishes on microprocessors, and this guy publishes on botany. The guy you're trying to match publishes on botany, probably the same guy. And so to make the semantic fingerprint, we attach every author that we've already disambiguated to every paper that we know they've written, extract every subject term from those papers using the thesaurus terms, and run them through MAI, of course, and we agglomerate them into what we call the semantic fingerprint of that author. So the goal is to build an author name authority file. Every authored record is linked to all the data associated with that author. Every DOI, or whatever document identifier number that you come up with, every co-author they publish with from every paper, so that when another guy comes down the pike that you're not sure, you can look at all the co-authors of all his papers, every institution they've been associated with, because as we know, people jump around. As long as you have data, you can perform a disambiguation operation. But because you have subject terms and because you have a fingerprint or subject profile of the authors, it really increases your accuracy of matching, and it really increases your assurance that you're matching people who you think may or may not be the same, because you look at the subjects they publish on according to your controlled vocabulary, which is fantastic. Just to point out that the raw subject term data and the thesaurus terms come from the same controlled vocabulary, and that's why we're able to perform this operation. If you have the subject term data, you have to compare apples to apples. You can't compare a subject profile from one thesaurus with semantic fingerprints from another thesaurus. So you have to have the same controlled vocabulary operating behind the scenes. And just as a quick snapshot, just like the institutions, we have an editorial interface that we look at the rejects or the kickouts, we call them the fallout authors, the ones who fall out of the disambiguation process, that the algorithm's not sure enough to match, are reviewed by editors. We get a list of guys who didn't match. I don't know when we took this snapshot, Jack, but there were 304,000 authors in the interface.
That was the test interface.
It was, yeah. It was just the slide that I still had. And so you have authors you have to disambiguate here, which the editor can look up and see if it matches someone in there. If even the editor can't determine that it's not the same guy, we add him as a new author. And it's an iterative process, like so many processes in the semantic world. Every time you get a new set of content in, extract names from, run through the algorithm, you're adding things to your authority file. So you should periodically just review them, make sure there's not junk getting automatically put in there, do cleanup of the stuff that's already in there, and let the editors are the ones on the ground that see the final process. So make sure to listen to the people who are doing the work. If they say, every time Father Christmas comes in, I have to hand match it to Father Christmas, it seems pretty obvious to me the algorithm should be picking up Father Christmas, so what are we doing wrong? And so listen to the people who have their boots on the ground, because they're the ones who see the final results of the process and have to deal with the stuff that falls out of it. And every data set is different. So the algorithm isn't a one-fit-all, a one-size-fits-all proposition. You can assign weights to things just like you do in semantic analysis. And you should look at those weights and modify them as necessary with whatever client and data set you're dealing with to make the algorithm as accurate as possible. And the last point, of course, is the central point. And I wanted to make sure I put it back in at the end of the program, which is leveraging your subject terms is a huge help in these disambiguation algorithms. You can certainly do it without it, but it really adds an extra level of matching, and a very accurate one beyond all the other stuff that you can use to try and disambiguate names. And that's all.